Commonly in NCEA you're going to see questions on either the preparation, so making, of amides, and or the hydrolysis of amides or polyamides. Regularly in the last few years there's been questions on hydrolysis of esters, or hydrolysis of amides, or hydrolysis of polyesters, or hydrolysis of polyamides. So they are really important concepts. So we're going to flip through preparation quite quickly, and then we're going to go through hydrolysis just a little slower, using this molecule as our context, so propanamide. So if I was wanting to make propanamide, we can use that as our context. Then there are three main ways that I could make propanamide. The first of those is that I can start with an acyl chloride, and so that would be propanoyl chloride, and react it with NH3. Now, is there any special conditions that the NH3 has to be under, or is it just aqueous? It does need. Double check that. Okay, so the general thing is an acyl chloride plus ammonia. Okay, and I'm pretty sure you're right, it has to be alcoholic. Because if you have aqueous ammonia, it'll actually react with the hydroxide ions in the solution instead and make the carboxylic acid. So therefore you haven't made what you wanted. So in our example, to make this, it would be propanoyl chloride plus alcoholic ammonia. That's really important. If you don't put an ALC, you've got it wrong, because it would actually make carboxylic acid and drive off HCl gas that way. This also drives off HCl, so it is quite a dangerous reaction to do in the lab, but still really worthwhile if you wanted to make these. If you were to put in excess of the acyl chloride, sorry, is this the right way? Yep. If you were to put excess of the acyl chloride, then it does continue to react. All right. So you can start getting things adding on to each other. Right. Acyl chloride plus ammonia. How else could we make one of these? It sort of links to the last concept we did, which was about what do we make in the lab? Esters. Okay. What can I do to an ester to actually make one of these? Now, I didn't cover this when we did esters on purpose. Wrong colour. What do you think I could add to an ester to break it or hydrolyze it and end up with one of these? If you're unsure, have a little look on page 136. Have a guess. You're trying to put a nitrogen in there. What common molecule could you put in there? Ammonia. Excellent. Now in this case, it is aqueous. In this case, it is aqueous because of the way it's reacting. You do need it to be aqueous. So in this case, it would be something propanamide. Something rather propanoate. So let's say, for argument's sake, so we've got methyl propanoate plus ammonia, and what that's going to make is propanamide plus methanol. So the methanol has come from there, just in case you're wondering where the keto got that from. So it makes an alcohol and your amide. But you can't react these two together to make an ester. So just be aware of this. It's an arrow, not an equilibrium. It doesn't go the other way. Okay? And there's one more way to do it. One more way to do it, which we'll quickly mention. And that is if I have the ammonium salt of carboxylate. So if, for example, I had, in this case, propanoic acid and I reacted it with ammonia, if I had with aqueous ammonia, then I'd end up making ammonium propanoate. If I then heat that, it'll thermally decompose. So the heat will break it up. and it will turn into propanamide. So it'll actually turn into the amide itself. So we can actually thermally decompose an ammonium carboxylate salt. So in this case as well, like using an example, if I had ammonium propanoate, I could heat it and I'd end up with propanamide, and it's actually water that gets driven off. So actually removing water from that, and it ends up making that. Once I've made my propanamide, which I've got here, this is only a primary amide, so it's nice easy one to work with, then there are some common reactions that we do. One is we could break it, hydrolyze it with the base, and one is we could break it with an acid. Alright, I was just thinking I probably should have gone for a secondary one because it's a bit easier to do. So if I was to hydrolyze this with if I was to add an acid to this, I've chosen a bad example, I should have gone for a secondary. Work better. Which one's your book got for hydrolysis? No, they've gone for primary, so it's fine. No, they've gone for primary, so we'll stick with that. Okay, so if I was to put this into a solution with these things here, then it's not like ammonium, it's not like ammonia or like an amine. It's not going to act like an acid or a base. It's kind of able to do both in a way, but it will actually remove things. Hydrolyzing it would break off NH3, basically. That's what you'd expect it to do. You'd expect this to break to make the carboxylic acid and ammonia, so an acid and a base. So this is what we'd expect it to be. CH3, CH2, COOH, and NH3. However, because one of them is an acid, and because one of them is a base, they do not exist together. So, what has to happen is if it's in acidic conditions, the base must turn into its conjugate acid. And if it's in alkaline conditions, the acid must turn into its conjugate base. So this is what it looks like. In alkaline conditions, you're going to end up with not methanoic acid. You won't not end up with propanoic acid, you're going to end up with the propanoate ion. So you end up with CH3, CH2, CO negative. So if you imagine that, that's the O from there being tapped into there. Plus NH3. And because ammonia is a base, it's not going to turn into ammonium in alkaline conditions. It's going to stay as ammonia. Alright? Conversely, if I do it in acidic conditions, I will get the propanoic acid, because under acidic conditions, it's going to be present as the acid, not as its conjugate base. But ammonia will turn into its conjugate acid, turning into ammonium. So if I have a look, this has had a hydrogen added to it, and this has had a hydrogen and an oxygen added to it. There's your water. Alright? Sorry, this would be a 4. My apologies. Sorry? So, yep, alkaline conditions, acidic conditions. Sorry, I missed the hydrogen there, ammonium ion. So you've got 1, 2 added there, 3, there's your H3, and there's your oxygen. Right, so if you actually think of it as hydroxide and H3O+, not as, for example, they might say sulfuric acid there, then it's easier to do your equations.